Oh, hello. You caught me experimenting in my ship of the mind. You may notice two things. A, I'm not in the void. I know. And B, I'm a bit more casual today. That's true. I wanted to look like a fun professor that taught you about philosophy, but in a cool way. So hello, and welcome to another edition of Because Science Live, where I take your comments, questions, and corrections live off the top of my head and try to get just as nerdy as you want me to get, except only in 30 minutes and expending a lot of personal effort. I have myself here, and I will be taking your questions from the chat. So let's see what's first up. But before that, I gotta get to the topic of this video, which is, do Halo's ring worlds, the Halo rings, do they have enough artificial gravity on them? Or could you create a comfortable 1G on Halo's rings? Well, artificial gravity on something like a ring world is going to come down to the radius or the diameter of that ring world and how fast the ring world is spinning. Its revolutions per minute is an easy way to think about it. If it is spinning quickly enough, given the diameter, then at the edges, on the inside edges of the ring, there will be a centripetal force, a reactionary force, pseudo or otherwise, that will give you a sense of weight that is equivalent to 1G because it will feel as though you are being accelerated out from the center at 9.81 meters per second. Now, canonically, the Halo rings are 10,000 kilometers in diameter. And if you put that into handy-dandy calculators that you can find online, you find that to create 1G on a Halo ring array, or a world, you get a RPM that is 0.01. That's good. The limiting RPM for something, a squishy being like us, you don't want RPMs much higher than 5, 6, 7, 8. You want to keep RPMs down, or else the Coriolis effect and other effects can make you feel sick on a spinning space station. So given that this is 0.01 RPM, yes, Halo ring worlds can have livable and comfortable gravity on them just fine, and they wouldn't have to spin too fast. You can even bring a ring world down to just 1 kilometer from 10,000, and it still wouldn't be spinning fast enough to make you sick while giving you 1G. So, Halo ring worlds, more sciencey than you'd expect. So, that's that. Let's go to your questions. I did a little bit backwards, but you know, I'm not used to the environment here. It's always changing. We have our first question from Victor Gonzalez, who says, is there a place on Earth where time could pass faster or slower than anywhere else? Actually, yes, but it would be a very, very subtle effect. So I think most of the time dilation that you've ever heard of has something to do with a spaceship, like I'm in now, or that's what it feels like, or a spaceship like I'm holding in my hand. When you go really, really fast, you experience time dilation, and you have to go relativistically fast, close to the speed of light, a good percentage, like 20, 30, 40, 90, 99% the speed of light. And when you do that, your clock, your physical, biological clock, starts ticking more slowly relative to the rest of the universe. So there is some speed at which, theoretically speaking, you could be traveling for an hour at that speed, and when you slow back down, the universe would have aged a year. You'd have to be going very, 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 very fast for that to happen, but it is theoretically possible. Now, is there a place on Earth where you could experience the same kind of thing? Yes, but the time dilation that you would want wouldn't be from moving very quickly. It would be gravitationally. So gravity also affects space and time and the way that you move through space-time. So objects with larger gravity have more effects on space-time, and it can have the same time dilative effect, which is a word, I'm pretty sure. So the heavier thing you're next to, the more time is slowing down. So is there a place on Earth? Yes. If you're near a mountain and someone is not, and you're pretty close, you know, you're at sea level, one person's close to a mountain, the other person isn't, they're experiencing more time dilation than you are. Or if someone is up in the air, in an airplane, for example, they are experiencing less gravitational time dilation than you are. So there are places on Earth where that makes sense, although the effect would be very, very, very small, because the masses we're talking about just aren't that big. They're not like black hole masses. It gets beautiful when you think about it, because I'm a fun philosophy teacher in this shirt, even though the effects would be very small, when you're sharing time with a significant other, because you are closer to some mass, time is slowing down for you just a little bit. I think it's lovely. Anyway, next question from Alessandro Russo, who asks, is cryostasis scientifically possible? So, if you're going on something like a spaceship, this one is from The Expanse. Watch it. If you're going on something like a spaceship, realistic spaceship travel is going to necessarily be slower than the speed of light. We don't know of anything that can go faster with mass than the speed of light. So, spaceships are going to be physics limited in their velocity, which means that it could take very, very, very long indeed to get to the nearest star or the nearest neighboring galaxy, like Andromeda. So what's a solution to that? Well, cryostasis was invented as a sci-fi concept. I don't know actually which one came first, but cryostasis is a concept that could get around this problem because it would extend the human lifespan. So even though it would take 1,000 years at some speed to get to some location in space, you would have your body suspended animation using very cold temperatures, and so you could extend your life and make it to that other star or whatever. There's other concepts you can look at, like generation ships, where you're not going to survive the journey, but your kids' will, and that's a whole other thing. But cryostasis, it's a tricky thing. I don't think we know of anything. Our human physiology right now isn't amenable to cryostasis. If you freeze solid, you die. Simply put. But there are animals on Earth that we could say take genetics from and genetically engineer ourselves or derive some kind of chemicals or something that, if you're talking in a science fiction-y kind of way, would make cryostasis for humans plausible. There's a tiny little frog called the American wood frog, I believe, and it's in Alaska and other places. And when the wintertime comes around, they let themselves be frozen solid. Frozen completely solid. Their metabolism, all the chemical actions inside their body, almost grinds to a complete halt, and these little frogs are frozen solid. But they have a physiology such that they have kind of like a biological antifreeze in their blood, and some of it has to do with like urea, which you can find in urine. But there's certain compounds in their blood which prevents it from freezing all the way through and prevents freezer burn, which is effectively when ice crystals form in cells and burst them. This frog can prevent that inside of its body and inside of its cells. And so it can freeze solid and have this kind of biological antifreeze keeping it alive, and then when the springtime comes, it thaws out and is fine. This is biological cryostasis on Earth right now. How would you do it with humans? I don't know. But a frog can do it, so hey, here's hoping. Next question comes from Daniel Castillo, who says, if the Earth for some reason started moving faster, can we get thrown into space? Or what if gravity becomes less strong? All right, so think of yourself on the surface of this planet. We are spinning, if you're at the equator, around 1,000 miles per hour. Like 460 or so meters per second, faster than the speed of sound, like Mach 1.3, Mach 1.4, something like that. So you're going very, very fast on the surface of the Earth. What is keeping you on the surface of the Earth? That is gravity, the attraction from the Earth's mass. And you can think of it like we're being held as organisms on the end of a gravitational string, being swung around in a circle. And if you've ever done that with a ball and a string, you know that if you were to let go, that ball would just fly off in a direction, and just fly off in a straight line in that direction. So if we're spinning very fast on the surface of the Earth, if you turn gravity off somehow, I don't know, infinity stones, then everything would act to fly off into space. I don't know if everything... No. Because if you turn off gravity, then escape velocity wouldn't be a thing anymore, and everything on the surface of the Earth would fly off into space at 1,000 miles per hour, and it would be an insane catastrophe. Sorry, I was just thinking about it. Good question. What's next? Vance1982 says, could you please explain for an ordinary person the Fermi paradox? Well, I don't know about for you, but for me, the paradox kind of... it comes down most simply to there are so many, I hope you caught that joke, there are so many planets in the universe that we know of now. We used to think that, the Earth was very, very special, but as we looked to the skies more often, we found there were billions and billions of galaxies, and not only those galaxies, but billions of planets as well. And now that we know that there are billions and billions and billions and hundreds of billions of planets, potentially habitable as well, some percentage of them, the chances that one of those planets would have evolved life, and even intelligent life like we did, gets pretty good. Even if life is one in a billion, let's say, then there are 100. No, sorry. Even if life is 1 in a billion, there's 100 planets just in our galaxy that have life on them. And so if that is the case, what the Fermi paradox says is that if that's the case, why haven't we seen any aliens yet? If there are potentially, just by the numbers alone, so many aliens and so many alien civilizations, why haven't we met any of them yet? I cannot off the top of my head go through all of the reasons, pro and con, what may have happened or not. I mean, there's some reasons like, well, maybe they're simply too far away, and because of the limit to light speed travel, they could never get to us in 10,000 years, and by that time their civilization would have died out or something like that. There's many reasons why the paradox may or may not come to pass. There could be aliens, but they're not visiting us. There's many, many possibilities for that. I don't know all of them off the top of my head, but you can Google it, and yep, you can Google it, and there's a lot of interesting research on it. But basically speaking, there are enough planets that we should have seen aliens by now, by the numbers, but we haven't. Why? Become an astronomer and figure it out. I mean, for me, that's what it means. Next question, we have Eric Misiak, who says, hey, Kyle, how strong would Spider-Man and Spider-Man's webs have to be to stop a train? Like in Spider-Man 2? In Spider-Man 2, Peter Parker shoots webs out and then holds himself against a train, and he stops a train. Now, I've been considering this for a full episode of Because Science myself, because you'd have to do quite a bit of calculation that I can't do off the top of my head, where you'd have to look at, okay, so you could take a train, average subway or train in New York City, get the mass of that based on how many cars you can see on it, look up the normal operating velocity or speed, whatever, for those trains, and then you can get the kinetic energy, which then you could work with maybe a kind of spring equation to show how strong Spider-Man's webs would have to be given how much they stretch. Now, you set up a chain of reasoning and you can find the answer. It depends on what numbers you use, of course, but I think you could go about a way to do it that would be interesting. What I would want to know is if there is, well, there is some volume, but what amount of actual spider silk would you need to stop a train? How many strands? What volume of threadage? Not a word. What's next? We have another question from Creative Comic Canuck. How and where does Aquaman go to the toilet? I mean, you know where the fish go. In the sea, I imagine. Are you talking about, like, differential pressures or something like that? Like, how... Is peeing at the very bottom of the ocean harder because of the pressure? And the fluids wouldn't want to excrete? I don't know. Sounds gross. I'm looking into it. I promise you. Our next question comes from Tongue Rot, sure, who says, hey, Kyle, what's your favorite suit aesthetically from the new Spider-Man game and why? Well, if you haven't played the new Spider-Man game yet, it's really, really good. My favorite suit is maybe well, that's kind of spoilery. I like the Spider-Man 2099 suits, I believe they are, because they look very angular and very futuristic. And if you were a Spider-Man-like dude, you would want something that goes beyond fabric, probably, to strengthen your joints as you're swinging around, kind of exosuity to protect you from small arms fire and that kind of thing. So I like the heavy-dutier. I like the heavier suits that are kind of Iron Man-y. Those are my favorite looking ones, and they look cool. I actually couldn't pick a suit. I kept jumping between each one because they're all pretty dope. Anyway, next question comes from Hershisers who says, "Hey, Mr. Hill." That's my dad. He says, Marvel has a character, I mean, you may be a he or a she, Hershisers. It's hard to tell. You sound like you're a Rick and Morty character. Marvel has a character that can turn her skin into diamond. What's her name? Emma Frost, I believe her name is? No. I've always wondered what other side effects this might have. If your skin turned into diamond. Huh. Well, we already have a lot of carbon in our system. We're carbon-based life forms, of course, and diamond is an allotrope of carbon, meaning that it is just carbon, but another form, like graphite or graphene, that kind of stuff. But what would it do to your skin if it all turned into diamond? It would depend on, I don't know, like the diamond packing density on that skin to see how hard it would be to move around now that your outside is rock and the hardest rock. I don't know. I'd have to think about it more. The first thing that comes to mind is that you could take a finger and go up to any glass and just do this and cut through it. That'd be cool. You'd be like Catwoman, only more expensive. Our next question comes from Hearn74656. Just Hearn was taken. A lot of Hearns were taken. Who says, question, if we made a Dyson Sphere, would the sun create an atmosphere within it? Wow. If you enclose the sun, would it create an atmosphere inside of the Dyson Sphere? I don't think so. I think the local gravity from the planets and such would be more than the gravity from the Dyson Sphere around the whole... Oh, well, no. Okay, I had that wrong. Dyson Spheres are just around a star. And you could get energy from utilizing all of the star's radiated power. And you just put it around the star, and you have some way of getting that power out. Would it create an atmosphere in there? Well, I don't know. I don't know what would happen if it's contained. I think you'd have to be pretty far away from the sun, or pretty close to the sun to have like appreciable effects with the corona. I don't know. I'm not an astronomer. But what I will say is that there is an interpretation of the environment around the sun that is kind of like an atmosphere. We use the effects of the sun and the pressure from the solar wind and the influence of the sun and its magnetosphere and such to define kind of what interstellar space is. So I think it's called the heliopause, if I remember correctly. So when we sent out a probe into interstellar space, we had to determine, okay, well, when is it actually outside of our star and the space around our star? And we use kind of this solar atmosphere, so to speak, with magnetic fields and solar wind pressure and stuff like that to define what is the end of our sun's influence. And I think you can kind of call that like the atmosphere of the sun, extending outwards, defining our cosmic place. I don't know if that answers your question, but I like how it sounded. Our next question comes live from, I look like Larry King. Our next question comes from Meow Indeed, who says, question, on the TV show The Expanse, how does gravity on spacecraft and the belt work? Wouldn't the belt asteroids be far too small and everyone would be bouncing around? Look, I field a lot of Expanse questions. I think we all know that I highly recommend The Expanse and that you should be watching it. Anyway. How do you create it on a ship? Well, I've talked about that many times before. This is the actual ship, the Rocinante, where the floors of the ship are actually orthogonal to the thrust. So you have ships oriented this way, and you have thrust oriented downwards. And when you do that, you can create artificial gravity by pushing, more or less, your feet into the surface. So I've already talked about that. But that's the belter gravity is actually one of my favorite things about The Expanse is that they made people who lived in the Beltalowda, they made them very skinny, very lanky, and very tall because when you're living on an asteroid, because it's not as large, it would necessarily not have as much mass and so not as much surface gravity. And so beltas would grow up under less gravity, and so they wouldn't be, let's just say, when they were developing, their spines wouldn't be compressed as much, so they could be taller over the generations as they grew up and evolved, really, on an asteroid as a separate population that wouldn't mix genes with the original Earth populations. So in a couple hundred years, couple thousand years, they might evolve in a way that makes them look taller, skinnier, lankier, which is such a cool little thing. Also, I believe in the Expanse series, I think it's series, they attach rockets to it and they spin it to create artificial gravity like a halo ring inside of the asteroid itself. And so if you get closer to the center of the asteroid, you have less gravity, and further out on the asteroid, you have more gravity. So those are a couple of very fun touches to hard sci-fi that I really like on that show. Our next question comes from Nathan Todman, who says, "Hey, Kyle." Whoa, what's up? He says, "Longtime viewer of yours, but this is the first time I've caught you live." Oh, exciting, isn't it? Look how casual I am. "I was wondering how dogs are able to smell things so well, specifically diseases such as Parkinson's." Well, I mean, you can get a little pseudoscientific with some of these things. So let's be as conservative as possible. Dogs have a sense of smell that is many, many times more powerful than ours. And you could say that they can pick up traces of scent, which is just molecules floating, atoms and molecules floating around in the air and biological remnants that approach the cellular level. And if dogs could do that, and if diseases change the expression of your cells inside of your body, maybe change slightly the chemical composition of your breath as it came out of your body, for example, then a dog could, in theory, pick that up. And so I'm not an expert on this, so there could be established studies or replicated studies on how good dogs can detect disease in people, but I know it is strong enough to theoretically start getting on that level. And I actually have a theory about this. It's kind of morbid, but I'm going to tell you anyway. So when you die, let's say you're put in the ground, and you die and you're put in the ground. Now, as your body decomposes, you create, I don't know if scientists call it this or just me. I think it's forensic scientists. Anyway, you create kind of like a death island where it's at the center is your corpse, and as you decompose, fluids and other materials and the rest of your body decompose and are dispersed around where you were buried or where you died. But they don't go forever, right? They just disperse kind of in a certain rate at a certain radii around you. So you have like this death island where this person's chemicals still reside. Now, if dogs can smell things down to the cellular level, down to the chemical level, they're that sensitive that they can detect certain traces up to many parts per million or parts per billion or whatever. Then whenever you hear of, you'd have to test this. This is just my theory. I'm speculating. But whenever you hear of dogs going and laying on the graves of their owners and not wanting to leave, perhaps it is because they can still smell and sense the island of that person that still remains there. That's just my theory. And it's kind of sweet and kind of gross. Two things that I love. Next question is from Aiden Ray. "Have you ever played D&D? If so, what is your race and class?" I've never actually played Dungeons & Dragons. I think I made a trade-off when I was a kid. I started playing Magic the Gathering when I was like 10 or 11. So I think that was my nerdy track that cost me a lot of money, and I still do today. So I've never played Dungeons & Dragons, but I'm actually playing a game that is basically Dungeons & Dragons the game, which is Divinity 2, Original Sin, which is really good. So I would absolutely get into Dungeons & Dragons. I love doing characters. I love doing voices. And if you want to tweet at Matt Mercer and say, "Hey, do a sci-fi one-shot and have Kyle on it," I'll do it. Couple more questions, maybe one or two more. Timur Shah, frequent commenter on the show, says, "Is it possible for humans to run faster with bionic limbs?" I would have to say, in theory, yes. That's why people were so worried when... Oh, did he get convicted? He did. When convicted murderer Oscar Pistorius... I'm not slandering him. It happened. Forgot this was live for a second. When Oscar Pistorius had the blades on his legs that were carbon fiber, kind of like kind of like kangaroo legs, I guess, is kind of an inelegant example. But people were worried that because he had this augmentation to his body, specifically limbs that were meant to be fast or faster, that he would have to compete with other with other athletes because he would be faster than they'd be faster than some people artificially. But if technology progressed and you had fully realized bionic limbs like you see in a game like Deus Ex or something like that, you can evolution has done an amazing job crafting and piecing together bodies and creatures and stuff like that. But it has not perfected our bodies. You could create synthetic muscle that would function, with 10 times the strength as our own muscle. So yes, in theory, I think you could go a lot faster. Take that, Usain Bolt. Although, if he had bionic limbs, it wouldn't be Usain anymore. It would be pretty insane. Last question. This is a good one. Our last question is from Joe Lock 314, who says, "Hey Kyle, watch the show with my niece Vicky. Whoa, nice. All the time, and she has a question. All right, Vicky, I got you. If our body's temperature is 98 degrees, then why does weather at 80 degrees feel hot? Well, our body temperature is at 98 degrees, and that's how our metabolism runs really well. That's just the temperature at which our metabolism runs well. But we are constantly producing heat, and we have to get rid of that heat. We are radiating, I think, in black body radiation, which is thermal radiation, which is stuff that you see with like an IR camera, of about 100 watts. Which is 100 joules per second. So you are always radiating heat. Now, if you're in an environment that's already close to the body's temperature, it's going to be harder we're anthropomorphizing a bit, but it's going to be harder for that heat that you are producing to disperse into the environment. Like how if you put, let's say, if you put a piece of metal at 100 degrees, in 100-degree heat, you wouldn't expect much heat transfer, right? But if that block was started producing heat, it would get hot because it's not expelling heat very effectively. That's what your body's doing when it gets very hot outside. It's trying to get rid of this excess heat, but it's already hot out, so the transfer of heat isn't great. When it's really cold out, the radiation coming out of your body is more effectively transmitted, I think. And that's all the time we have for this edition of Because Science Live. Thank you so much for watching everything on this channel this week. Not just the vlogs, not just the live streams, but also the main episodes. Go watch the latest episode of Because Science if you haven't yet, about Master Chief falling from space and whether or not he could actually survive. And follow us. Just search that name, follow it, like it, share it, and all that stuff. Have a wonderful rest of your weekend. I got to get back to my work. Be nice to each other, because this is all we got.